Alright, so this video is going to be covering section 11.2, and it's called Standard to Vertex. We're going to be starting out with our equation in standard form, and we're going to be changing it to vertex form. I'm going to do something a little bit differently today. This is actually your worksheet that you're going to be assigned today. I'm actually going to go through and do all of the odds on your worksheet, and I'm going to have you do the evens for your homework for today. Okay? So remember, standard form of a quadratic is ax squared plus bx plus c, and vertex form is a times x minus h squared plus k. So the first section is just kind of a review from yesterday. We're just going to state which form the equation is given in. So number one, that is standard form. I don't see any parentheses. We have x squared, x, and a constant term. So this one is in standard form. Number three is also in standard form. And number five, since they have those parentheses squaring that, this one is in vertex form. Okay, and then number seven, we want to identify the vertex and the axis of symmetry. So again, kind of review from yesterday. Think about your transformations. Plus 2 on the inside goes left 2. Negative 10 on the outside goes down 10. Right? So here's my vertex. The negative out front is going to flip it. The 4/5 is going to make it kind of fatter. It's a vertical compression. Probably should have drawn it even fatter than that. But that's basically what the graph looks like. So the vertex is at negative 2, negative 10, and the axis of symmetry is at x equals negative 2. It's always the same as the x value of the vertex. So this time I drew the picture. You don't really have to draw the picture unless it helps you. If it does help you, please do. But notice here that the inside number is just changing sign. The outside number stays the same. That's our y value of our vertex. And then the axis of symmetry is at the same x value as our vertex x value. So for number 9, the vertex is going to be at negative 310, and the axis of symmetry is at x equals negative 3. All right, the next section is just asking us to identify the min or max value of each. So in order to determine if this has a min or max, we first of all need to find the vertex, because the vertex point, that is always the min or the max. If it is a parabola that opens upward or it's concave up, then that point would be a min because it's the lowest point of all the points around it. If it has a negative out front and it gets flipped, then that vertex point is a max. So this is asking us to identify the min or max, which means we need to find the vertex again. Once we have the vertex, we need to state whether it's a min or a max, right? So it's going to be a min if the a out front is positive, this a right here. It's going to be a max if a out front is negative, right? So this one's going to have a min because the 2 out front is positive, so it's going to be opening upward, concave upward. And the vertex is at negative 310, so that's the coordinates of that min. Okay. This I said I was doing odds, but I'm actually going to do number 12 because it looks a little bit different. So I'll have you do 13 and 14. So this one is actually missing the x term. So this one is actually in standard form in a way, but it is also in vertex form because I could write this as negative 8 times x plus 0 or minus 0. Doesn't really matter because it's 0 squared minus 5. Okay, so this is telling me that my vertex is at 0, negative 5. Okay, incidentally, I could also write it as negative 8x squared plus 0x minus 5. So it's really kind of one of those odd or rare cases where it could be considered in either form. Okay. But the point would be at 0, -5, and then that negative out front, that's going to flip it, right, so that it's concave downward. So this is a max point. All right, so the next part is a bunch of quadratics that are given to us in standard form, and we need to change it to vertex form. Okay, so a couple things we need to know about this is that standard form, again, is ax squared plus bx plus c, and vertex form is a times x minus h squared plus k. All right, so I could put y equals in front of either one of these. Okay. So in these two equations, we have the same a. So a is the same in both forms. Okay, so that's just kind of a note we need to know. A is the same a. In these equations, a, b, and c may change, but if it's a quadratic and it's in standard form, x squared and x and y won't change. Those will be there. Those will stay there all the time. It's the same with the vertex form. Y and x are always going to be here. That squared will always be there. It's a, h, and k that we need to find to get it into vertex form. So in order to find the h value, we're going to use this little formula. H is equal to negative b over 2 times a. Okay, so that's what h equals. That's how we're going to find it. Once we have h and we have found what h is equal to, then we can find k. So we can't find k until we've found h first, so always find h first. And then in order to find k, we're going to take our function, the original function that we're given, so like in number 15, this, right? And we're going to plug the h value that we just found in the previous step here. We're going to plug it into the function and solve for y. That's going to give us that k value. Okay, so on number 15, what we're doing is we are changing it so that it looks like y equals a is something that we have to find, so I'm going to put a blank here. Okay, and then it's going to be x minus blank squared plus blank. So again, the y and the x, those are going to stay y and x in the equation. We're not actually trying to find those. Those are still the variables in my equation. What we're trying to find is the a value, the h value, and the k value. All right? So again, like I said, a is the same a. So in this number 15, a is -1, right? Because a is in front of x squared. So I would just put -1 right there. Excuse me. Now, in order to find h, I need to do this little formula, negative b divided by 2a. So in 15, a is -1, b is 8, and c is -19. So in order to find h, we're going to do negative b, so -8, b is 8, over 2 times a is -1. Now, be careful when you're doing this in your calculator, because if you if you don't do it the order of operations correctly, you're going to get the wrong answer here. You always multiply before you divide right here, right? This is a grouping symbol, right? And we have to do what's up here and simplify it, and what's down here and simplify it before we can actually divide. So this is actually -8 divided by -2, which equals 4. So 4 is our h term. It goes right there. Now notice here that the h that I found is +4. But when I put it into the equation, it's -4 because my original general form of the equation has a negative in it right there. And remember the inside lies. So if my h is 4, my equation is x minus 4, right? So it would, on the graph, it would go right 4, which if the coordinate of the vertex is h, right? The x value is h. It would go right 4, not left 4. And then, so now we have h, now we can find k. We're going to find k by taking our function, which is right here. I'm replacing the y with an f of x, or an f of h in this case. And I'm going to, but our h is 4, so let's put 4 there. I'm plugging 4 in to for x in each of these places. So negative 4 squared plus 8 times 4 minus 19. So notice here that this negative was already out front and my 4 was positive. So in this case, I would actually be multiplying 4 times 4 before I apply the negative. Now, if this were a negative 4 that I were plugging in, then I would be doing negative 4 times negative 4. But since this negative was already in front, I don't include it in my squared term here. So this would be negative 16. 8 times 4 is 32 minus 19. So that would give me 16 minus 19, which is negative 3. So that k value is negative 3. So now I've already written it there, but I'm just going to rewrite it. Negative 1 or negative times x minus 4 squared minus 3. This is the equation in vertex form. Okay. So let's try another one. Let's do number 17. So on number 17, we have a is equal to 4, b is equal to negative 16, and c is equal to 17. So again, we want to put it in this form here, the vertex form. So we're going to have y equals blank times x minus blank squared plus blank. We have to find a, h, and k. So a is the same a, so that's just 4. B or h is equal to negative b over 2a. So h equals negative 16 over 2 times a. So remember, simplify each of these first separately before you divide. So this is 16 divided by 8, which is equal to 2. So 2 goes there. And then 2 is the number that I need to plug back into the function in order to find k. Right? So k equals f of 2. So take 2 and plug it back into the function. This would be 4 times 2 squared minus 16 times 2 plus 17. All right, so again, remember your order of operations here says I need to square 2 before I multiply by 4. Okay, don't multiply 4 and 2 together and then square it because 4 is not squared, only 2 is. So this would be 4 times 4, or 16, minus 32 plus 17. Okay, 16 plus 17 is 33, so this would be 1. 33 minus 32 is 1. So 1 would be our k value. So 4 times x minus 2 squared plus 1 is vertex form. Okay. We'll do one more. We'll do number 19. I'm looking at the other ones over here. They all look pretty straightforward. On number 18, we are missing our constant term, so that just means c would be equal to 0, but you can do it exactly the same way. Okay, so on number 19, a is equal to negative 1 again, b is equal to 4, and c equals negative 5. So again, we're trying to put it in vertex form, so I'm going to put the skeleton of that equation up here. So y equals blank times x minus blank squared plus blank. So a is the same a, so this would just be negative 1 out front. H is equal to negative b over 2a, which is negative 4 divided by negative 2, or 2. And k is equal to the function evaluated at our h value, which is 2. So negative 2 squared plus 4 times 2 minus 5, which would be, remember, do the exponent before the multiplication. So this would be 4 times negative 1, which is negative 4, plus 8 minus 5. Negative 4 and negative 5 make negative 9, and negative 9 plus 8 would be 1. So negative 1 times x minus 2 squared plus 1 would be the vertex form. All right, so you try 16, 18, and 20. 21, we are going to find or state the transformations, and then we're going to state whether it is a max or a minimum, and then we're going to sketch the graph. Okay, so finding the transformations and whether it's a max or min, those are things that we can only see when it is in vertex form, right? And this number 21 and 22, they're in standard form. So the first thing we need to do here in order to see what transformations have happened and whether that's a max or a min is to change forms. So we're going to change to vertex form. So remember that's a times x minus h squared plus k. So a is -1, and that one just goes straight over. H is equal to -b, and our b here is 6 over 2 times a, which is -1. So -6 divided by -2 is 3. So h is 3. And then k is equal to the function evaluated at 3. So take our function here, -3 squared plus 6 times 3 minus 11. So this would give me -9 plus 18 minus 11. So that's -20 plus 18, which is -2. So this would become -2 out here. Okay, and plus a minus, that's just going to give us minus. So here's my function in vertex form. So now I can see that this went right 3 and down 2. So it said to state the transformations. So this went right 3, it went down 2. Okay, the negative out front would have reflected it down or across the x-axis. And the 1 is a 1, so that doesn't stretch or compress. It's just timesing it by 1. So we go right 3, we go down 2. There's the vertex. And because it's been flipped, it looks like that. So this is a max point. All right. Let's see, did we do everything? Yes. Okay, so that's 21 and 22. On 23, it's a story problem. We're going to read this and figure this out. So Uncle Rico throws a football in the air. The path of the football is represented by h of t equals -4.9t squared plus 19.6t plus 58.8. Here, t is the time, and h is the height of the ball from the ground. What's the maximum height that the ball gets from the ground? So this is a quadratic. It's in standard form. That negative out front tells me it's been flipped, but also the path of a football or something thrown would kind of follow that path, right? So in order to find the max height of this football, so here's time going by. Here, that's the x-axis. The y-axis would be the sorry, it should actually probably be over here. So the y-axis would be the height. So if I find that vertex point, the x value is going to be the time, the y value is going to be the height, and I'm looking for the max height. So what I'm really looking for is the height of the vertex. This is a little bit confusing because here I'm meaning h to mean height, not the h that was in up here. The vertex on all of these is located at hk, right? Because h is the one that moves it side to side, so that's the x value of the vertex, and k is the y value of the vertex because that's what moves it up or down. So this h right here and this h right here are two different h's. This one is talking about the x value of the vertex. This one is talking about the height of the football. So I could also write th as hk, but h doesn't mean the height. When I write it that way, that just means it's the x value of the vertex. This h means what I'm actually looking for is the height, and it will be the y value of the vertex. So I'm actually looking for k. So what I'm going to look for here is k. All right, so in order to find the vertex, I just do the formula here. So this one, I don't technically need to actually put it fully into vertex form. I certainly could, but all I really need to do is find h and k because I'm trying to find the vertex. So h, oops, sorry. So h is -b, so b is -19.6, or it's 19.6, and I'm putting a negative in front of it, divided by 2 times a, and a is -4.9. So that would be -19.6 divided by, let's see, that would be 9.8, right? -9.8. And I want to say that is just 2, but let me double check. my calculator. So negative 19.6 divided by negative 9.8 is equal to 2. So h is 2. So now I'm going to plug that in. I'm going to do f of 2. And that's going to give me negative 4.9 times 2 squared plus 19.6 times 2 plus 58.8. So I'm just going to quickly put that in my calculator. Remember here, I have to square 2 before I multiply by 4.9. So that's 4 times negative 4.9. And that is negative 19.6. So plus 19.6 times 2 and plus 58.5. So that is equal to 78.4 feet. Was it in feet? It didn't actually say what unit it was in. So just 78.4. So 78.4 is the max height. The vertex is located at 278.4. So h is always the x value of the vertex, k is always the y value of the vertex, but in this case, the height is represented by the y value of the vertex. Okay. All right, so number 24 is one that you will need to do on your own, huh? Just realized. Okay, so you guys just do the evens here. If you have any more questions, please email me and we will answer those. And I hope you have a great day.